Dr. Coskren again with his 2-minute mineralogy and chemistry lesson.
Okay.
I have a sample here that I just got in the mail yesterday. It's a Baryte, which is barium sulfate, except that this has a very significant and fairly high impurity in it. It's barium radium sulfate, which means it's quite radioactive. The question is, how is there any radium to go into it? Because radium, the most long-lived isotope, has only about 1,000-year half-life. It should be all gone. But radium also is produced from the fission of uranium. And in uranium ore, you set up an equilibrium where the uranium and radium are in a constant ratio, where the radium is being produced by the uranium as fast as it's decaying. Then the radium is leached from the uranium ore, washed into the groundwater, and reacts with sulfate to form the radium sulfate, which then of course decays very rapidly, but it's been produced recently enough that it's still here. So this particular sample comes from a deposit that does have uranium in it as well, and that's why the radium is here at all. It's a very rare form of baryte, which is very good because we don't really want much radium wandering around. This, by the way, this radium is the source of radon in the atmosphere, because the next step is radium goes to radon. Okay, that's it.
Good. And we're not showing the back. We're gonna flip.
Oh, there's the label for it.
Wow, that's interesting. Okay, thank you so much, sir. Yay.